Welcome to The Explainer. So, you've built a cool AI agent prototype. Now what? How do you actually get it ready for the real world, for production? That's the big question, right? Well, today we're going to break it down, pulling some amazing insights from the recent TypeScript AI Conf. We'll look at the three big pillars you need to build a truly resilient AI agent. So, let's start with a pretty wild idea. What if your code could find and then fix its own bugs? I know, it sounds like something out of a sci-fi movie, but it's not. The folks at Replit are actually doing this. They've built agents that can do just that, and they call it build time autonomy. We're talking about an agent that doesn't just test your code, it goes in and debugs it for you. And get this, 40%. That's how many bugs their testing agent managed to find and fix completely on its own. Just think about that for a second. That's a huge chunk of tedious, time-sucking work that developers deal with every single day, just automated away. It's an incredible showcase of just how powerful this whole build time autonomy idea can be. But of course, there's always a catch, right? This incredible power, it comes with a hidden weakness, a kind of fragility. See, these autonomous agents work by linking together a bunch of different steps, kind of like a chain. And a lot of those steps involve calling out to a large language model. Now, a single one of those calls, super reliable. But the problem is, the chance of failure starts to stack up with every single link you add to that chain. And this chart, wow, it just lays the problem bare. It's what you could call the reliability cliff. You start off great. One step, you're at 99.8% success. Awesome. But then you start adding more steps. 50 steps, and you're down to 90%. 100 steps, and that's really not a lot for a complex agent, and your success rate just plummets to 80%. An 80% success rate means 1 out of every 5 times you run it, it's gonna fail. You can't ship that to production. No way. And this really gets to the heart of it, a quote from Luis Villa at Replit. He said, "Failure is not only not an option, failure is inevitable." I mean, that's a pretty stark way to put it, but it's true. You can't just hope for the best and try to code your way around failure. The models themselves are unpredictable, other tools can fail, it's gonna happen. So you have to plan for it, you have to engineer for it. Okay, so if failure is inevitable, how in the world do you solve this reliability puzzle? Well, the answer is a really powerful concept called durable execution. The easiest way to think about it is like an intelligent checkpoint system in a video game. If something goes wrong, you don't have to start all the way back at the beginning. It's a core idea behind frameworks like Ingest. So let's just put these two approaches side by side. You've got the traditional way on the left, any little hiccup, any single error, and boom, the whole thing has to restart from scratch. It wastes time, it wastes compute, and honestly, it's just super frustrating. But now look at the durable workflow on the right. It saves its state after every step, so when something fails, it can just pick up right where it left off. It's so much more resilient. And the difference this makes, it is dramatic. By switching to durable execution, Replit took their agent success rate from that shaky 80% all the way up to 96%. 96%. That is a huge leap. So here's the big takeaway from all this. Yes, failure is inevitable. But, and this is the important part, it is also engineerable away. You can absolutely build systems that expect failure and know exactly how to recover from it. Okay, so we've tackled reliability. Awesome. But making an agent that doesn't fall over is really just the beginning. To be actually useful in a real production environment, your agent needs a whole supporting cast. It can't just exist in a vacuum. It needs a solid application stack. This leads to a really important question. What's the absolute minimum viable data stack that an agent needs? And luckily, a whole panel at the conference dug into this exact topic. A big theme that came up over and over was keeping it simple. You might think giving an agent tons of tools and data sources is better, but it turns out the most successful agents have a smaller, more focused, and super reliable set of tools. And this is what they landed on. 4 key pieces. First, you need a database, your single source of truth. Then, you need a hybrid vector search so the agent can find relevant information both by keyword and by meaning. Third, a blob store, basically a place to dump all your raw, unstructured data, like files and images. And finally, and this one is so important, an observability layer. You have to be able to see what your agent is doing to trace and debug it when things go wrong. This whole conversation about making tools and systems that agents can actually use, it led to this bigger idea that Netlify has been talking a lot about. They're calling it Agent Experience, or AX for short. It's kind of like the next step after Developer Experience, or DX.
The idea is to shift your thinking. You're not just designing systems for humans anymore. You're designing your entire ecosystem so that AI agents can interact with it reliably and successfully.
All right, let's do a quick recap. We've got a resilient agent, we've given it a solid data stack to work with. Now, how do real people actually use it? That's the final mile, right? We need to connect our agent to the user with a proper front end. So, how do you build the UI for your agent? Well, as Nico from Vercel pointed out, there's the brittle way and the right way. The brittle way is just manually writing UI components for every tool the agent has. The problem? If someone changes a tool's name or one of its inputs on the back end, the UI just silently breaks. You might not even notice. The right way, the type-safe way, is to have the UI's types automatically generated from the agent's own tool definitions. That way, if anything changes on the back end, you get an error when you try to compile the front end. It catches the bug before it ever gets to a user.
But look, just having a UI that works isn't really enough, is it? We want it to be delightful. Think about it from the user's perspective. When the agent is off thinking and executing a tool, what does the user see? A loading spinner. A long, awkward pause where it feels like nothing is happening. It's like a black box. That's a pretty bad experience. But the good news is we can totally fix it. The solution is to create what's called a streaming UI. And how you do it is actually pretty clever. You basically convert your tool functions into something called a generator. This lets you yield little updates and pieces of the result as they become available. So instead of one big chunk of data at the end, you're streaming information directly to the UI in real time. The user gets to see exactly what the agent is thinking and doing step by step. It completely opens up that black box.
Okay, so let's tie this all together. The journey from a cool prototype to a real production-grade application, it really rests on these three pillars. Number one, expect failure and build for it from day one with durable execution. Number two, give your agent the tools it needs with a minimal but observable data stack. And number three, connect your agent to your users with a UI that's not just functional, but type-safe and even delightful to use. So what we've seen today is that building a production-ready agent, it's so much more than just the core logic or the clever prompts. It's about engineering the entire system, from the back end all the way to the front end, with resilience and the user experience in mind. Your agent is now reliable, it's connected to data, and it has a great user experience. The only question left is, what complex real-world problem are you going to solve with it first?